all the ships hovered, right? Well, why did they hover? Decibel. And I see this thing that looks kind of wild, right? I'm like, what is this thing? Cool. And one of the big differences was that hard drive. Ended up developing the graphics tech for Civilization 5. We wanted to build technology specifically so that we could make the games that nobody was making.
Hello, welcome everybody. Today I'm joined by Dan Baker, who is an engine programmer and an amazing game developer. We're going to be talking about his game engine that him and his team have built and the new games that they're releasing, why they built a custom engine, and get into some interesting stories behind that. So welcome, Dan. Thank you very much for being here. Really happy to have you here and excited to have this conversation.
I'm happy to be here. I'm really excited to talk about this subject, and I'm glad you're here asking me.
Yeah, this is going to be fun because I've been looking into what you've been doing quite a bit, and it seems really interesting. You're working on a different type of game, something that's kind of outside the norm for what I'd say 90, 95, 99% of developers are working on, to the point where you've actually built your own custom engine to make this happen. And I want to get into why and how you did that. But first, I'm curious if you could share the story of kind of how you got into game development.
Sure. I guess my love of games comes from a lot of people, and I was just a kid. And at the time, I played a lot of PC games, and my mom had bought she was going back to school, and she had bought a 386-33, megahertz, a state-of-the-art machine. And so when we had that machine, all of a sudden I was able to play a lot of great PC games. In particular, I got the Ultima series. I think it was like Ultima 5 or 6. I can't remember. Maybe it was 6 at the time, and it came on floppy disks, and you had to install it, and it just blew my mind. I was like, this is the most amazing thing ever, because I had a Nintendo, and I loved it, and I had a Genesis, and I loved it, but console games are just very different beasts than what you had in PC games. So that was the time I really just became in love with PC games. But at the time, this is the 90s or early mid 90s. Game development industry wasn't really that big. And so like the idea of actually having a career in the game industry was like about as fanciful as being a rock star, right? Or
there
being
were probably like a couple dozen, right?
Exactly, a baseball player. So like there was really no way that you could do it, and my parents like didn't think that was real clear. I didn't even think it was real clear. So anyway, fast forward, I went to school, and I really got into computer graphics. I really loved computer graphics, and what got me into that was actually Jurassic Park. So you remember the very first Jurassic Park, and
I remember seeing it in theaters.
Yeah, and so there had been computer graphics in movies before. Like I remember The Last Starfighter was a little kid, watched it, and I was upset because I wanted to see the previous Starfighters instead of the last movie, because I was so young I didn't know what that word meant. And they had computer graphics there, but they had always done spaceships and artificial things. And then Jurassic Park came out, and so we knew graphics could do like spaceships and stuff. But until Jurassic Park came out, the idea was like, oh, you couldn't do organic stuff, like that was not a computer graphics thing. And so I remember when I watched Jurassic Park, and there weren't very many scenes that did it, and they looked terrible by today's standards. But when you saw these dinosaurs come on the screen, and they were computer generated, and it just blew my mind that you could do that with a computer. And so after that, I said, that's what I want to do. I want to do computer graphics. And so when I went to college, I went to Boston University, and they had a graphics group there. So we had these SGI Silicon Graphics work machines, are really high end, because you couldn't really do it on a PC at the time. Until by the time I graduated, you could, because that's how much the industry changed. And so we had these SGI machines, and we had this graphics group there called BUG, the Boston University Graphics Group. And so when I joined that group, it was all these really graphics enthusiasts who got into graphics and really started learning from each other. It's actually funny because Natasha, who's a year ahead of me in the group, who's one who founded the group, she's actually just recently the CTO of Activision now. It's so funny. Oh, wow. So like this group, like this weird group of people who came out of Boston University, and many of them are like Rockstar and these various other studios, all became like super big in the game industry years later. It was really kind of interesting. So that was where my love of graphics came from, and I got educated at Boston University with this group that was just sort of doing cutting edge stuff back when there weren't a lot of people doing it, and we're really into real time stuff and game stuff. And so then, fast forward, it was 1999. I got an internship at Microsoft at the DirectX group. I realize now is a really coveted position. It was really hard to get. So it was in the DirectX group. It was not a big group. Everybody thought on the outside, this is like 100 people. It actually turned out it was like 20 people. And so I got an internship there. And I know at the time, it's probably bigger now. And I get in there the first day. This is 1999. And I go into my boss's office, this guy named Colin McCartney, a thick Scottish accent. And I get his office and first day, and there's this box on his desk, and it's an open board computer system. I don't know if you've seen a lot of those test circuit things, like if you get them for review and stuff, and it's like just an exposed motherboard and like RAM slots and all that stuff on like, pegs and stuff. So no case, or everything was external and easily accessible. And I see this thing that looks kind of wild, right? I'm like, what is this thing? Day one. And it was the only one that ever had. He said, oh, this thing. Well, this thing, we're calling it an Xbox, but it's just a prototype, and that's just our code name for it. We're never going to call it that if we actually decide to make it. And I wish I had a picture of it, because I just remember it very distinctly. I remember him very distinctly saying, we're never going to call it Xbox. It's because it's from the DirectX group. So don't let anyone else tell you differently. It was because it was in the DirectX group. They called it the Xbox.
That is hilarious.
He's the one who named it. And that was just the code name. And I remember thinking, that's actually a pretty cool name, at the time. I didn't say it out loud, but I was like, that's a pretty cool name, actually. And that was so cool. I saw the Xbox, the very first prototype. And what it was actually, at the time, the prototype was a little bit different. It was a GeForce 2 and like some sort of, I can't remember the CPU, some sort of Intel CPU. And effectively what they had prototyped was it doesn't sound like much now, but they had prototyped a PC that could boot in 7 seconds. And back in 99, like one of the different consoles in a PC was a PC took like a minute to boot.
Yeah, at least.
It was very, very slow. Now it's really fast, but it was really slow. It's so like a console, you just put the game in and went. And so the thing they were trying to do is like, shit, well, can we get a PC to actually boot that fast so you could play a game on it? And so that's what it was. And they did it. They got it booting in like 7 seconds. And it was pretty cool. And one of the big differences was that hard drive, which was really controversial at the time. So when I'm there in the summer, 99, I was really on my own because he was so busy working on this thing. And there's only like 5 people working on it. I mean, this is very early on it. This is the prototype. I mean, it's a very early prototype. It's just a proof of concept, really. And he was really busy on that. And so I just remember the day that he disappeared to pitch it to Bill Gates, was the CEO then, and to pitch it to Bill Gates. And Bill Gates was a scary person to pitch in front of. Like, he was notorious for like telling you your idea was terrible and very other mean language. Like he was notorious for that. So he was very nervous about it. And so he disappears one day in the summer. And then the next day I see him and I ask him how it went. And he said, wow, it went really, really well. I think this is going to happen. And it was really interesting. So I was there when I wasn't at the meeting, but I was there at the aftermath of the Xbox getting decided that, hey, we're going to make it. And it was pretty cool. And the reason it ended up getting called Xbox, I think, this is my theory, I don't have evidence for this, ended up being the actual product name, is when I was there, it was really secret. But then they had this town hall where they had like a lot of employees in our building and our larger group. And they talked about all these things they were working on. And they talked about the Xbox. And it was so radical because, at the time, like now, of course, Microsoft made games. But at the time, like the idea that Microsoft would make games was like preposterous. So they had this meeting. And hundreds of people, and the contents of that meeting got leaked, and all of a sudden there was all over the internet Microsoft making an Xbox, right? And that's the name of it. And I know it came out of this meeting because it was like the day after this meeting happened. So I know somebody in that meeting leaked it. And then sometime later, and they decided to go it. They hired a marketing firm, and they said, "How what are we going to name this?" I've been through this process with Microsoft on Aura, actually. So it's a very complicated process. There's all these things that go into it. And apparently what happened is the marketing said, after a lot of research, said, actually the best name turns out to just be Xbox.
Yeah, so I can see that.
And because it already had traction and people since it had already been on the web. So it was really interesting, like how it accidentally got named Xbox because an engineer named it Xbox, and then it got leaked, and then it already had a reputation. And then the marketing said, actually, that's a good name. So moral of the story there is like, yeah, you got to actually be careful about the code names you give stuff. because it could easily end up being the name it ends up being.
That is a great lesson and an awesome story too. I think through that. I've got to remember that too. Just don't use terrible names or bad places. Xbox was a good one, luckily, but there are much worse options it could have been. And I've seen some terrible code names internally in a couple places, and luckily those never turned into actual products. Well, that's really, really interesting. So you were working on DirectX then back in kind of the early days, which I assume, and you kind of mentioned that you were already heavy into the graphics programming stuff. So is that kind of, I'm curious, I want to dive into the engine now and the games that you've been building with it. But is that what kind of pushed you down that road? And what was it? I guess, can you talk a little bit about the engine development that you've been doing since then, and how you started up with the current game, the current engine, or the previous game and the current engine, and how that all kind of came about? I'm curious to know like what the mindset was, what the goals were, and what the problems were you were trying to solve, and then why you came to the conclusion to build your own setup instead of using maybe one of the options that was out there or using something you had built previously. Can you dive into that a little bit?
Right. So a little bit of my background. So after Microsoft, at Microsoft, I worked on DirectX Scream, and I specifically did language for making shaders, or GPU language, called HLSL. And after doing that, I wanted to get back into PC development, because I was building the tech for it, but I wasn't actually making the games. And so I was like, I really want to make especially PC games. And so I left Firaxis back in 2006, and this is my favorite game at the time, and still probably to this day. It was a game, Civilization. I joined Firaxis, and that's where actually I met a lot of the other people at Oxide, and ended up developing the graphics tech for Civilization 5. Again, with a lot of the other people here, for not just for the graphics, for other parts of the game. And so after that, because at the time, back in 2000, so Civ 5 shipped in 2010. At the time, there were really no options. You really just had to build an engine for it. Well, there were engines that existed. They really weren't at all for strategy games. I mean, Unity, I don't even think existed.
Yeah, and Unreal was all for FPSs, and
exactly.
Still very expensive back then.
Exactly. So it's expensive. So we sort of had to do our own thing. And one of the things that we realized is it's actually quite hard to make a strategy game from an engine standpoint, because one of the reasons you don't see engines built for it is that the game's just so big in terms of scale. There's just so much going on. There's so many different units. There's so many different things that can be on screen. It may not seem like it because the game is waiting for you, so it's turn-based, but the game has still got to display, at the time it was like, we called it draw calls, like thousands of draw calls, which at the time was like hard to do. So we had a lot of custom tech for that. And so after we did that, we really wanted to push the envelope even more. And when we started Oxide, one of the things that we knew is that there's a lot of great tech out there. So Unity was coming on, Unreal was coming on, they're great tech. But the problem that we noticed is that people were only making the games that were easy or possible to make with the off-the-shelf technology. And there started to be beliefs about what could and couldn't be done that weren't really true. They were just things that the engines could or couldn't do, not what the computer could or couldn't do. In particular, there was a lot of problems with using multiple CPU cores. It's called draw limited, or they couldn't handle that many objects because they were designed for like FPSs. And so one of the founding principles of Oxide is that we wanted to build technology specifically so that we could make the games that nobody was making, right? Specifically to make the games that there was a hole in the market because off-the-shelf engines weren't able to do it easily, and the technology was a limiting factor, because it turns out that there's a lot of game designs that just weren't happening, not because people didn't have a good idea, just because the tech couldn't do it. And that's the genesis of wanting to build the engine. So we, in particular, are trying to build an engine that was going to have the power to deal with a player in a more open-ended game that could do a lot of different things. Because the challenge that you run into with a game like Aura, for example, is that the player can build numerous cities, numerous numbers of units, there's buildings, and the amount they can do is so much that you need an engine that can handle the scale of what the player's imagination is. And so we really approached it from the standpoint of like, hey, let's build an engine that's not going to break when the player goes and plays a game on a giant map and has all these cities and all these things. It doesn't want to, not going to crash. It's not going to go to 2 frames a second. And that's really the genesis of why we really wanted to build our own engine, specifically for that, to build these things that people hadn't seen before.
I think that's the best reason for it, and it probably makes a lot of sense for RTS games, strategy games, and like you said, all the different types and the different genres that aren't really common. And I've seen that you mentioned designers, having awesome designs and then they can't build them because of the tech. I've also seen a lot of the time where people have this grand vision for a game and then it gets scaled down and trimmed down into what fits into our current tech stack or what our current developers feel comfortable building. Not really what's technically possible, just what we're comfortable with. And it seems like you've back in the old days, I say back in the old days, before I was heavily into using game engines, I felt like, especially like early 2000s, late 90s, everybody was building, you built custom stuff for the custom game that you wanted to use. And then you might reuse some parts of those, but you weren't necessarily reusing everything, and things were kind of custom design for that, which has a lot of benefit there. And I assume you mentioned that you're not seeing these performance dips and you're able to do all of these things. Has it been really successful? That's been my impression, is that building your own engine for this, and the engine name is Nitrous, right?
Mm-hmm.
The Nitrous Engine.
Yeah.
Yeah. Has it been a good hit for you? How has it been going so far? Can you talk a little bit to that?
Oh, sure. So yeah, nitrous is a little bit of a pun. So you make a nitrous oxide, and then we have some of our tools is iron oxide. There's this whole theming we do.
It's fast, right?
Oh yeah, actually I want to back up a bit because this is a story I haven't told. Is like, why did we call it Oxide Games, right? And I'll only get into the Oxide first because I just thought of this story. So I know we're a little aside here. So the reason we ended up calling it Oxide Games was because when we started the company, I had a discussion with some marketing folks. I think that was actually the AMD marketing folks. And one of the interesting points that they said is that it turns out that if you have an X in your name, you're more likely to make a headline. And then, yeah, I'd never heard this before. I was like, oh, well, that's interesting. And I don't know if it's true or not, but they were sure convinced it was true. So I was like, okay, that's interesting. So when we started trying to name the company, we thought, okay, we need a simple, easy to remember, easy to spell name that's like the way companies are named. You think like Bungie or Blizzard, or I mean, that's just the way people name. There's a way that people name game studios, right? So they said that's what we need. So we just started thinking of all the words we could that had an X in it. And we had so many cool names, man. It was like this huge list. I found it the other day. But here's the thing that happened to us. When we started going through the names, we would get to the trademark thing, and every single name that we thought of that was cool was like, nope, someone has that. Nope, someone has that. Nope, someone has that. We had this giant list. I don't even know. It was like 50 names. And we went, name, and every single name, someone somewhere had like, I don't know, state of Connecticut, someone made a hot dog stand called that. Great. It was like, it was really discouraging. And finally we got to Oxide, which sounds like such an obvious name. Like we didn't think that we would be able to like get it, but we put it in I remember typed it into the like little trademark database. Nothing came up. And we're like, wait, what? It's so literally we on the spot just registered the trademark. Like it was just so instant because we had been so frustrated about not being able to get a name. And we finally came across a name that we could trademark it. Boop, trademark. So that was how we ended up being named Oxide Games.
Oh, that's great. It's hilarious how all these things happen. I never would have guessed. I would have thought it was some big process.
No, it was literally
had all these puns ready.
Yeah, it sort of reminds me of the Xbox story. So getting back to the original question, I felt like I got a little sidetracked there. It was, how successful has it been? Well, that's an interesting question because one of the reasons that people don't build custom tech, and frankly, I think a lot of studios are wise not to do it, is actually really hard. Like the requirements and technical expertise is really high. It's not so much the cost of it, like in dollars and cents, because I don't think that actually using an off-the-shelf engine saves you any money. I've never seen evidence of that. When you add up the total engineering cost, like you could do this, you could get an estimate for how much time you spent in engineering with or without an engine. And it turns out when you look at it across the board and analyze it, there's not compelling reason to believe that licensing engine actually saves you any money. especially since you buy the engine. But the problem with it, building an engine, is the time thing. It takes a lot of time. So if you don't have the time to get to market, it's going to be an issue. And then the second problem that's actually harder, it's hard to find the people who actually know how to do it. It's like if you want to build a rocket engine, how many people out there actually know how to build it? As it turns out, not very many. And so it's really difficult to even find the people. But since Oxide was founded by people who knew how to build engines, that was something that we knew how to do, and also how to hire other people who knew how to do it and train them. In terms of how successful it is, we made our first game, Ashes of the Singularity. That game was really designed to let us ease into the building the engine. So we just avoided certain things. We were able to build parts of the engine in that game and really get our feet off the ground. For example, if you actually close that game, all the ships hovered, right? Well, why did they hover? Well, because we didn't have the time to build an animation system. So we said, instead of building an animation system right now, let's build everything else, and then we could build the animation system later. And so it was a good project for us to build a foundation for the engine without having to build like every little thing. Fast forward, once we had a lot of that technology in place, when you're going to get to a project the size of R, we already had a good foundation in the engine. We still needed to do a lot more work. I would say that in terms of success, having done a lot of profiling work on Aura over the last 6 months, and just seeing the amount of stuff that's rendering, to give you an idea, it's like there are situations where on the map, the renderer and visualizers part of the game are requesting over 100,000 things to be rendered, and the engine handles it fine.
Nice.
It actually clusters them up and reduces it, so it only has to draw like a smaller number. And it's really clever about how it does it, and it's using like every CPU core, so that the frame rate on a good system could potentially be still 90 frames a second doing this. So it's quite amazing to actually watch the amount of data load that goes on, and that's simply because if you're really into playing the game and you're doing all these things, it just turns out that that's how big the world the player is making or is getting to. And I can say that in terms of success, I count the successes. I can tell you with a surety that this game would not be possible if we didn't have the custom tech, because even with all the work we did to thread out and use all the cores and to be efficient at every core, it's still using a lot of CPU power, right? So I'm looking at and we stress drivers and things that in ways that I know other engines haven't seen, because we find bugs that are new to the driver guys. And threading issues that are new to them, because I know we're hitting it harder than other games are, hitting their software harder than other games are. So I could say that we just couldn't have done it, and we couldn't have done it without DirectX 12 either. Like we just never have been able to build this game. So in terms of success, I'd say, well, the success is that we actually able to make R at all. Like it wasn't a question of could you use another engine to make R. Like if we had used some off the shelf engine, we couldn't have built R. We could have built something else. We probably built something good, but it wouldn't have been this game.
Right. So it sounds like it's been very successful then. The goal was build this giant, massive game, and it seems like it's actually worked, which I think is great. It's impressive, and it's exciting to see this kind of game. When I first heard about R, which wasn't that long ago, unfortunately, I wish I'd known about it a long time ago. It's exactly the kind of game that I love to play, like these massive scale games. Civilization, huge fan. City Skylines was my addiction for months just recently, and all RTS and strategy games. Command and Conquer Generals will still probably be my favorite forever, or 0 Hour. But
yeah, some people here actually worked on some of the Command and Conquer, believe it or not.
Oh yeah, that was my favorite by far, the 0 Hour, and it was largely just like the mixing and matching and building up a team of like I've got nukes, and you've got super the defense. There were lots of I don't want to go. Yeah, it was fun.
We geek out about that all the time.
Flashbacks.
Yeah. So one of the other things I forgot to mention about our tech that also needed a lot of custom work is our game is procedural. Most of the tech out there is designed for what we call bespoke levels, where artists are hand making these carefully crafted experiences. But in our market, in our game, it's a procedural content. Every time you play, it's different. And so, the other axis of innovation on our engine that we've equally invested a lot in is just that procedural generation, and in particular, procedurally generating the maps, procedurally generating the cities, procedurally making these guys animate all along the map. There's an enormous amount of work that we did to make that work, because the idea is that people could play the game over and over and over again. And so it's super critical. Like you couldn't imagine, like if I told you, hey, you're going to have a Civilization like game or 4X game, and oh, by the way, it's an exploration game, and by the way, it's not a procedural map, it's always the same map. You would say that's terrible, right? And like no one would want that. So that was another big challenge. Is like, how do you actually make a good quality graphic quality game that is actually procedural? And it turns out that it's such a hard problem that a lot of projects just abandon that, and they end up being like one bespoke level. And we really were committed to like, no, it's not a bespoke level. You hit that button, a new game, you get a new map every time.
That is awesome. I didn't even realize that was. Yeah, I've got to get in and hopefully play soon. I'm excited about that. I think it looks really exciting. It's just my kind of game. There's a lot of it seems like content in there too, though. I was curious what that process was like, because a lot of the developers watching especially would be familiar with using Unreal or using Unity and putting some data in there, but most of them have probably never used anything custom, or maybe some of them have and they've used some of their custom tools from whichever engine at the company they're at. But what do you do for that? What's that process like if I want to go create a new unit or something like that? Did you go build a whole system for that? Is it pretty simple, or is it really just custom for the game?
Oh, that's an excellent question, actually. And I could literally give an hour, 2 hour, 3 hour talks, and we're probably going to give some extra material on this too. So, there's different halves to this question. One is sort of how you do the art pipeline. And, for that, we have some plugins and stuff for the various art tools. I think we use mostly 3D Studios, a little bit of Maya. And there's a fairly involved process for that, just because it's hard to build an asset for the game, like a model and stuff. There's a lot of technical things. And that process actually hasn't been too bad. It's definitely not as slick as something like Unreal or Unity, but we've managed to have artists be able to make stuff in our game and work. And it's also in a way that makes our engine able to render lots and lots of them without issue, and to procedurally put them, because that's the constraint more than anything. In terms of the game design, so we actually invested a lot into this version, the Nitrous 2 version of the engine, and we built our own data language and format system we call ZNO, or Zinc Oxide, or ZData. And it's a very, very powerful and very straightforward language. It's based on some of the data types that C99 uses. And almost all of the game is actually expressed in these ZData files, which is a language, like a data language. And it actually has a text form, which is relatively straightforward to modify and very human readable. And we also can compile it to a binary form that's very, very fast to load, even though the text form is also really, really fast.
Yeah, it seems really cool. And like I said, this game looks like a lot of fun, and it's exactly my kind of game. When is it coming out, by the way? Do you have a release date?
I don't know if I'm allowed to say, so I'll punt that question. We have said, I think that we said fall. I think that's been said.
And are you guys going to be showing it off at GDC?
We are not doing anything official at GDC. However, our AI architect is going to be giving a presentation how the AI works in Aura at GDC on the Monday. That's a very, very, very exciting thing, because our AI is extraordinarily sophisticated in this game, way more sophisticated than any other strategy game I've worked on. And I will also be giving a talk at GDC on our some of the rendering architecture. These are very detailed, geeky talks. There are parts of them already publicly available, so we're going to try and have some parts of it available outside of GDC. But yeah, if you're at GDC, come check them out.
Yeah, that sounds exciting. I want to see the AI stuff, especially because I'm actually working on some AI stuff that's probably nowhere near the level that you guys are at for my own project. So it'd be very interesting to see what I can learn from that. All right, that's very, very exciting. I guess the last thing I was curious about was if you had any just general tips or advice for game developers who kind of want to follow your path and be a graphics level and engine level engineer, because like you said, it's hard to hire for. There aren't very many. They're very high demand. It's probably like technical artist and graphics engine programmer, like the best paid, most sought after positions, but very, very few people I think are able to really get through that process. Do you have advice for people who want to do that, want to kind of be the next Dan?
Yeah. I don't even know if my path in the industry is replicatable. Like, I tell my own stories. I'm like, how in the world was I there when that? Because it's just some of it was just random luck.
Just got to get an internship at Microsoft.
Yeah,
first, right?
exactly, at the stage, and then have your boss work out. Yeah, it's like, how do you quantify that? However, I would say that, like, I think that looking back, the thing that probably helped me the most that wasn't obvious at the time was I really liked math. So when I was in school, I got a degree in CS and I got a degree in math. And that degree in math was invaluable more than this. I didn't even need to get the CS degree. Like, I was going back and doing over. I wouldn't even get the CS. I would just get the math degree. I would take CS classes, but the CS classes didn't teach me how to program. You don't need to go to school to learn how to program, but you should go to school. But the math is a lot harder to learn on your own. And that was super useful. And especially designers, I was just talking about it today, how much, especially in the strategy space, comes down to solid understanding of mathematical relationships, how much actually ends up being differential equations, how much ends up being these relationships, and having a solid principled understanding of it is super helpful.
Oh, I think that makes sense. And to be honest, and I think about it, almost every engine programmer I know had a math degree. So I think of it like they're math professors before they became engineers, or interesting. Well, I think that's some really good advice. Hopefully people are able to get in there and start making some of their own things. Again, I think probably, like you mentioned, just for the games where it makes sense, where you want to solve a problem and make games that other people aren't able to make it and get out. I think that's very cool. And it's very impressive what you guys have done there. So, I just wanted to say thanks again, Dan. Do you have any other final words for everybody out there?
Final words are, thanks for listening in. Some of the stuff gets super geeky and techy, and I always enjoy. I know myself, I always really enjoy YouTube's when someone's getting really deep into the subject. But yeah, thank everyone for listening and to all the great stuff, and thank for taking an interest in us.
Yeah, thank you for making the game. And if you haven't already checked it out, make sure you go check out Ara. And what was the name of the previous game? I have it in my queue now to add. I wanted to go check it out, but I haven't played it yet.
It's a game called Ashes of the Singularity.
Yeah, I saw it and I was like, how did I not know this game existed? Again, RTS games are my thing. So it's something I'm going to be playing this weekend. So thanks again, Dan. Go check out Ara. Go check out the Ashes game. And don't forget to like and subscribe and all that stuff. And then check out Dan at GDC if you get a chance. And who's the other speaker? Sorry.
Will Chambers.
Will Chambers. So go check out Dan and Will. I'm going to go jump into both of those talks when you guys are there. So thanks again. We'll see you in the next video, guys.
Thanks.
All right. I'll stop.